about this one right here, where they ask you to write it as a negative exponent, right? We said that you're normally not going to do that, but you just have to realize that you can do it, right? If you have a positive exponent, you can still take it across that fraction bar and make it into a negative exponent if you wanted to. Okay? So, for instance, the last one, we did 1 over 25 yesterday, didn't we?
Yes.
Yeah. So what would we say is an exponent for 1 over 8? For 1 over 8.
Oh, I had a different question.
Okay, hold your question. What? So in other words, for 8, what could we write using exponents that would turn into an 8? 2 to the third, right? So if we had what they had on the board, or up on the screen, 1 over 8, Addison says 2 to the third. So then when they ask us to write it with negative exponents, we would write it as what? 2 to the negative 3. And again, so I don't like these ones, but I think they just want you to know that you can rewrite it from positive to negative, even though our number 1 rule yesterday was we can't have this as our answer, right? Unless they absolutely ask us for it. Okay? The other things that you're going to do then are algebraic expressions again. What's that mean? If it's an expression, it doesn't have an equal sign. So we're still going to solve, but we're going to solve problems that don't have equal signs. The only way that we can honestly solve them, though, is what? If they give us what each of those variables means. Okay? So in this case right here, it says, find r to the negative 2 if r equals negative 4. Okay? So basically now, we're going to take whatever they told us and substitute it into the problem. Remember now, if I have a negative, I always want to put parentheses around my negative number, especially if I have a even exponent. But again, I would just get in the habit of putting parentheses around negative numbers if they're raised to any power, so I don't get confused when I do and when I don't. So now I'm going to get rid of my negative exponent by writing this as what?
1 over negative 4 squared.
Perfect. And then remember, anytime that I can figure it out, I'm going to figure it out. So what would we have? 1 over
Negative 60.
Think about it. Positive 16. Because why? Negative 4 times negative 4. And again, that's why we need the parentheses, right? Because if we were to not have our parentheses and stick it in our calculator, then we're going to get a negative, right? Because the calculator is not as smart as we are. Some of us, anyway. That has our calculator.
I don't know that either. I'll go with paycheck.
That's a deadly combination, you two together.
What do you mean? We can be my vice president.
Yeah. All right, try this one on your own. A to the negative 5 if A is 2. What's my answer? Again, if I can do the numbers, do the numbers. That might mean I have to do some math. Otherwise, if you have a calculator, you can punch that one into your calculator. Now, here's the difference. If you have a calculator or not, if you do have a calculator, you're just figuring out what a to the 5th is. Don't put 1 divided by that number and get a decimal. We still don't like the decimal answer. So just make sure that you write this as a fraction. So we would say 1 over 2 to the 5th, right? So a to the negative 5th, we move down to a to the 5th, but a is 2. And then we have to figure out what 2 to the 5th is. So 2 times 2 times 2 times 2 times 2.
They're 2.
You're wrong, Colbeck.
Wait, what?
1, 2, 3, 4.
What? This is about as easy as it gets, Colette.
1, 2, 3, 4, 5.
Oh.
You gotta count this as 2,
Oh.
right? 2 times 2. So 1 over 32? Okay, how about this one right here? If I write this, here's the question. What is raised to the negative 2 power?
The answer of the.
So, here's the question. Could I write this problem right here as this?
No.
What do you think, Colbeck? Everybody says no? These two things right here, exact same thing, just different ways of writing it. Because anytime that the exponent is outside of parentheses, it means that that exponent goes to every single part of the problem on the inside. So negative 2 is to the A and negative 2 is to the B. So there's a couple different ways of solving it though, also. So I could rewrite it like this, and then I would rewrite it as 1 over A squared B squared, and then put my numbers in. Or I could do this and write it as 1 over AB in parentheses squared. Now let's see if we get the same answer. If I put my A and my B in over here, I get 2 squared times negative 3 squared underneath my 1. Everybody agree? Yes? No?
Yes.
Okay. What's 2 squared?
4.
What's negative 3 squared?
9.
What's 4 times 9?
36.
So I'd have 1 over 36. Would you agree with that? Okay. How about over here? If I put my numbers in now, I'd have 2 times negative 3, but that's all inside the parentheses that's squared. So what's 2 times negative 3? What's negative 6 squared?
36.
And I still get my same answer. So it's all kind of how you see it, but just realize that both of those mean the exact same thing. Everybody see how I did that one? So basically I'm following the order of operations over here, or in a sense, I'm kind of distributing this exponent to every single piece of the inside of my parentheses. Now we don't really say it that way, but that's essentially what we did there, that we distributed it through there. And so you can do it either way, and you're going to get the exact same answer. It's just kind of how your melon thinks about it. And trust us, we don't want to be inside of all of your melons. Be a scary, scary deal. Right? All right, so questions here. Everybody good with all that, or you need more examples of those kind?
Can we do one more example?
One more like this kind?
Yeah.
Sure. So again, the most important part of those kind of problems that Miley's asking about, or just in general, is that you got to make sure that you go nice and slow and understand what is happening to the problem. So let's try one even more complicated. Let's do A to the negative 4th times B to the negative 3rd. And see what we get here. It's probably not really complicated, but.
Are they still the same?
And yeah, we'll use these ones.
Okay.
Still use these ones. And again, as you're working through this, right over here, when we had 1 over 36, don't ever punch that into your calculator. We don't want a really long decimal. We'd rather have a fraction. And I know you guys probably think it's way easier with the decimal because I get it in my calculator, but again, if we take away the calculator using a fraction, it's gonna be a lot easier than using decimals. So on the bottom, this is gonna be a big number, isn't it?
Is that supposed to be 2 to the 4?
Right? So, first thing I did was move my negatives to the bottom so they became positive exponents. Then I substituted in, then I started simplifying. 2 to the 4th, 16. Negative 3 cubed is negative 27, because negative times negative is positive times negative is negative. And then I just multiply the two together to get. But again, I would rather leave it as this than punching it in my calculator and get a big long decimal.
So, in your answer, could you put the negative sign down on the bottom?
You can put this negative sign up here, down there, out there, all means the same thing. Just one negative sign. Okay? Questions? Perfect. Rest of the time is yours. You got a lot of time. Just about 23 minutes or so, depending on how late the clock is. So, Alex, make sure you look at 47 through 52. It says slow down and think.
You should be telling that to Nathan.
What do you mean? I think all the time.
We can.
Yeah, we have a calculator.
Did Kovac just say it thinks all the time?
Yeah.
all the time.
You have always taught math though.